Hello guys, my name is Sandeep and today what we are going to do? Simple thing. Our chapter that is stars and solar system, right? Sure. So first of all, we know what are the different stars, do you know? Right? In our, let's say, solar system, or let's say about universe, right? So yes, star, you can see a lot of stars in our sky, right? And what about sun? We know the sun is a star, right? Obviously, Earth is rotating around the sun. That's very good. So tell me one difference. Why that other stars are very long away, and our sun is showing that yellow color and it is twinkling. Other stars are twinkling, we can say, right? And very small they are. Right? I already told you the reason also, right? Because they are very long away, we can say, right? That's why they do look very small. What about the twinkling? Yes, do you know, anybody know why they are twinkling? Yes, because the light which is coming from those stars, right, are entering in our atmosphere. And our atmosphere, there are a lot of variables in our atmosphere, like density, we can say, or refractive indices, are some points like that. Therefore, light do not travel in the straight line. It varies. It's, we can say, zip zap. It is going in zip zap fashion, right? Therefore, we can see those stars as twinkling. Okay, so chalo, we have already talked about stars. We'll see the more in detail in that in this lesson today. What about what are the other things in the universe? Do you know? Right, our universe is very big, right? Okay, so what are the other things we have in our universe? Tell me. Yes, those are sun. We already know. Planets. We already know. Moon is there. That is satellite, right? Okay. What else? Scientists are researching on those things, right? Recently we have also got one image of one element, if you do remember that one, that is black hole. That's very good, right? So we have the black hole, we have the different types of galaxies there, right? So all those forms our universe. Do you, anybody can tell me what is the age of the universe? Yes, that is 14 billion years old. 14 billions means lot of zeros after 14, right? Okay. And do anybody know what is the size of the universe? Size of the universe is, it is almost 93 billion light years. So there are a lot of concepts in here. So let's see what are those concepts. Right? So when I'm saying the size of the universe, this is actually only the observable size. Means we can observe this much of universe, and we already know the universe is infinitely long. Now let's see what is the 19 billion light years size means what. So first let's focus on light years. Now you can see, you will say that years is the unit of time, right? We do measure the time in year, but no, light year is the unit of distance, right? So what is the meaning of light year? First of all, let's consider that one, then we will see about the sign. So now light year is the unit of distance. The meaning of that is, in 1 year, let's say x distance is traveled by light. What I'm saying, 1 year, we already know 1 year is 365 days, right? Now we can say whole year. So in whole year, consider if the light starts from this point, what distance it will travel in one whole year. Time is given as 1 year. So for that purpose, I will need the speed of light. Yes, everybody know these things, right? Light also have the speeds, as we have the speed of our bike. Our bike speed is how much? Let's say 45 kilometer per hour. When we are riding the bike, it is 45 kilometer per hour, right? Or driving the car, let's say 100 kilometer per hour. If someone is very good at the racer, we can say they could go up to the 200 kilometer per hour. That's it, right? So what is the speed of light? Anybody know what is the speed of light? Yes, so speed of light is 3 into 10 raised to 8 meter per second. So this is the speed. So in a 1 second, how much distance it will travel? So it will be this one, this much. Right? So these many zeros we can say. So something like this. Okay, this is meter per second, right? So very high distance it will travel in only 1 second. So you can imagine how much distance it will travel in 1 year. Now we have to calculate how much is the total seconds are there in 1 year. We have to multiply it by 365 days and 24 hours, then 24 minutes. Very big calculations, right? So this is the distance. And what we are seeing here, our observable universe. Consider this is the observable universe. Then this whole distance is 93 billion light years. This is only the observable. We don't know how much it extends, right? So we can say universe is infinite. Okay. Chalo. So let's start with our chapter now. Now, what we are going to cover in this chapter, let's see. So first one is introduction, as well as then we have the phases of moon. We are going to study something about how the moon revolves around the earth. What are the different phases, right? If you do observe the moon every night, you are not going to see the same circle, right? Moon's shapes are different every day. Why those are different? We are going to see those things. Then let's talk about stars and their life cycles. Life cycles means you will say that how the sun could have the life cycle. Yes, sun also got born. Sun also get dead, right? There is a death timing for some sun too. Okay, as well as for other lot of stars. Then we have pole star. What is pole star? What is pole? Right? We know for Earth we can say North Pole is there, South Pole is there, right? So pole star some will have something to do with that, right? We will see that one too. Constellations. Constellations means what? There are a lot of groups of stars, we can say, right? Now we are going to call them as constellations. Then solar system, you already know a lot of things about the solar system, right? So how many planets are there? Can anybody tell me? That's right, there are 8 planets, right? When I used to be in the school, and that time there were actually 9 planets, right? So I know that everybody knows the 8 planets, names of the 8 planets. And anybody tell me the name of the last ninth planet? Right? That is not actually the planet. Now it is removed from your planet system. So yes, that is Pluto. Right? So our last planet, now it is called as dwarf planet. It is now called as dwarf planet. Why they removed the planet Pluto from our system of planets? Now you said that those are now, no, there are not 9 planets. Now there are 8 planets. Why the Pluto is removed from that? Right? There are some criterias for the planet, for any celestial object. Celestial means objects in the universe, right? Celestial object to be called as a planet. So we do have a lot of definitions. Similarly, planet also have definitions or criteria. We can say there are actually 3 criterias, and Pluto can only uh, manage to define only 2 criteria. We can say, right? So let's take a quick look. What are the criteria? What are those criteria? First criteria was, or is, we can say, for the planets. So when we can say any object is planet, the first criteria is it should move in it should move in elliptical orbit. This is the first criteria. Second criteria is shape should be spherical. We know our earth is spherical, right? It is not flat. There were times that people were believing that the earth was flat, but now we know that it is spherical shape, right? And last one is it should clear the neighborhood. It should clear the neighborhood. So what is the meaning of that? Let's see what is the meaning of. We know the first and second criteria are easy to understand. So every planet, obviously, we can say every planet can complete all the criterias, first, second, and third. Pluto also covers 2 criteria, but Pluto does not complete this criteria. There is third criteria. First of all, let's see what is the third criteria says. So if this is sun, Consider our Earth is here, and we know Earth is moving in elliptical orbit like this. So what we can see, consider there are a lot of materials inside the space in the orbit also, right? Some dust we can say, or stones, something like this. So what actually Earth do when Earth moves to here, it cleans this. Means because of the gravitational force or any other forces applied by the Earth, this dust or any we can say spam material will flow away from the orbit. So Earth actually, when it is performing the orbit, it is clearing this whole thing, right? So this should be the one of the criteria, and Pluto cannot complete this criteria. Therefore, we are calling that Pluto is not a planet; it is the dwarf planet now. Okay. So this is about the Pluto and why Pluto is removed. Then we know about the solar system. What are the other members? You can see here the names: asteroids, comets, meteors, right, etc. Then we also have the satellites. We know about the moon. What are the satellites of the different planets? We will see that, and about the artificial satellites, right? We will also see that one, right? Artificial satellite. You know that those are the man-made objects, and we do launch the artificial satellites for that one. Okay, sure. So let's start. So as I already discussed about this one, stars, why the stars, this should be stars, appear to twinkle, right? I already discussed about this one, right? Why they are twinkling. And there are two different things we can say: stars and planets. Stars do twinkle, planets do not. Why? Because stars do have their own light and planets do not have their own light, right? So this is the main difference between stars and planet. You should remember. Okay. Then moon is our natural satellite, Earth's natural satellite. It is the brightest object in the night. You can see up in the sky, you will see the moon there. It is the brightest one. And this astronomy, the study of celestial objects and associated phenomenon. So this is called astronomy. Very very interesting subject of the one of the branch of we can say of the physics. So if you want to pursue science, this could be the one of the very interesting branch, right? Most of the scientists do prefer this astronomy thing. They, because obviously mankind is very curious about what is happening in the universe, other planets, and the most of all is to find the alien life, right? So everybody is waiting when we do find the alien life, right? So you can pursue this branch of physics. That is very very good actually. Okay. Then this study of all this celestial object which we call astronomy, right? Even from the or you can say old times, past times, many scientists, even from India also, they used to study this and prepare the calendars, things, then almanacs, right, etc. Then they could also understand the effect of climate, rainfall patterns, right? When rain will form, we know that now we got the weather reports and etc. Right? What should be the crops, right? What should be the seasons? We know there are three important seasons: rainy season, then we have winter, then we have summer. Then when should be the festivals, etc. All things are dependent on the study of this astronomy, we can say. Okay. So, so first of all, let's say what is celestial body. You know, celestial body includes all the stars, planets, galaxy, everything, right? Black hole, you can say, satellite, you can say, asteroids, you can say. All these things are celestial bodies. Okay. Then, as we were talking about the observable universe, right? So we have seen that size is 93 billion light years, very large size, right? We cannot even measure that size normally. Right? So obviously these sizes are measured using the high technique instruments there. Okay. Then, there are celestial objects, right? Why these celestial naturally we can say celestial objects are there naturally, right? For example, sun, moon, right? We cannot explain why those are there, but obviously there is a very long process. If you do know, you must have heard something like Big Bang theory, right? So this is the one theory how the universe started. It says very initial, that is 14 billion years is the age of universe, right? So they say that before 14 billion years there was a single point. Everything is in that single point, and there was a very big explosion, and everything in the universe started from this single form or single point. This is just the Big Bang theory, we can say, right? Then, so as we have seen, all the systems, planets, then galaxies are the celestial objects. Okay. Then, now important thing to notice to study here is the phases of moon. You know the moon. Moon is what? Moon is the natural satellite of Earth, right? Okay. So what is the meaning of phases of the moon? Right? If you observe the moon every day for consider 1 month, if you observe the moon for 1 month, will you see the moon in the same shape daily? No, right? Shape is going to change. Therefore, those shape changing, we are going to call those as phases of moon. Okay. So let's see. Here you can see one of the phase. Sometimes you will see the moons like this. Sometimes it will be exact circle, right? Exact circle. Though I am not able to draw the exact circle, but let's say this is the exact circle. Okay. Okay. Now, here what we are going to say, these various shapes of the bright part of the moon, means white part we can say, right? The various, that is bright part, which is actually showing the some light there. Okay. So various shapes of the bright part of the moon during the month are called as phases of the moon. So this we could say, this is the definition. They could ask what are the phases of the moon. You can say the various shapes of the bright part of the moon as seen during the whole month or 1 month is called as phases of the moon. Okay. So when we say that there is a full moon means what? You can see whole sphere, whole disk we can say. So when we can see the whole disk on particular day, we cannot see that daily, right? So on particular day, we can see the whole moon. We are going to call this as full moon, right? In India, there is another name for it. It is Purnima. We also call it as Purnima. Okay, so on Purnima there is a full moon. Okay, so you must have heard that Guru Purnima is there or any other Purnima that day. Remember, there will be full moon on the sky, in the sky. Okay, then after what happens, consider Purnima is there, means the full moon day is there, or full moon night we can say, right? After next day, if you saw that one, saw the moon, you will observe that the moon is reducing its shape. It is getting reduced in shape, right? So after that day, you can say size of the bright part of the moon appears to become thinner and thinner, right? And exactly after the 15th day of the Purnima, moon is totally invisible. You cannot see the moon, right? And this day, we call it as new moon day, or in India, there is another name for that, Amavasya. They could ask this, right? Remember this one, Purnima and Amavasya. Purnima means full moon. Amavasya means there is no moon at all in the sky. Okay. Then, now after the Amavasya, if you check the moon at the next day, you will see very small portion of the moon, right? So it will be something like this, very small portion. Right? So this portion, so next day after the Amavasya, it is called as crescent day. Remember, it is Amavasya or new moon day. Okay, so this is the crescent moon, and after every day now it is again going to increase and increase again after the 15th day we are going to get the full moon there, right? So full disk, right, which we will call it as Purnima, right? So what we can see, in whole month there will be two Purnimas, right? 15 days. Similarly, two Amavasyas will be there, right? Like that. Okay. So these are the phases of the moon. Now, according to this, almost all the festivals in India are celebrated according to phases of the moon, right? Here you can see Diwali is celebrated on the new moon day. You haven't noticed this obviously, but you can notice, right? Whenever Diwali is there, it is a new moon day, we can say. Then Buddha Purnima, right? As I said, Guru Purnima is also there, right? Those are celebrated on full moon day, we can say. Then Mahashivratri, it is the 13th night of waning of moon. Waning of moon means what? Decreasing. The shape is decreasing. We are going to call it as waning. When the shape is increasing, we are going to call it as waxing. So simply, when the Purnima is there, the days after Purnima, right? Shape is becoming like this, right? It is decreasing. So this is waning. And Amavasya, when Amavasya is there, there is no moon, I can say. Obviously, there is nothing, so I cannot show no moon. Then this is crescent. We have said this is crescent. Again, the shape will start increasing like this, right? These are waning, and these are the increasing shapes, we can say. Okay. So we also seen the festivals. Festivals are on the phases of the moon, different phases of the moon, we can say. And what is the time period of one full moon to the next full moon, right? So one full moon to next full moon is slightly longer than 29 days, we can say. This period normally we do call it month, right? Normally we do say that for moon to rotate around the sun, it will take 29 days. Okay. Sure. Now, what are the causes of this different phases of the moon? Right. So as you can see, as I said, that the brightest thing you will observe in the sky any day, right? Except Amavasya, we can say, or the no moon day, right? It is the moon, right? So tell me, can moon have its own light? No, obviously not, right? Moon does not have its own light. So why we can see the light of the moon? Simple thing, we can see the light of the moon because consider this is the sun, this is the earth, and let's say this is small moon, right? Obviously, comparatively, it is smaller than earth and sun is the biggest one. So sun's light goes here up to moon and gets reflected here, right? That's why we can say there is a light of the moon, but moon does not produce its own light, right? Okay, so here we can see the moon. We can see the moon because the sunlight falling on it gets reflected towards us. Okay, so we can see only that part of the moon from which the light of the sun is reflected. So every day, obviously, we can see the different parts, not whole moon. We cannot see the whole moon daily, right? If you can even consider sun, about the sun, in daytime we do see the sun, right? But sun is always circular shape like disk. We never see the phases of sun. Why? Because sun produces its own light. It does not need anybody else. But moon is dependent on sun to get light, and moon is going to reflect that light, right? So it depends how much part of the moon is getting the light from sun and how much part it is reflecting towards the earth, right? Therefore, there are different phases, different sizes, we can say. Again, we talked about the waning. Waning is what? When the phase moon in which its size is decreasing. Waxing means it is increasing in size, right? Waning means it is going from full moon day to Amavasya or no moon day. And waxing means it is going from no moon day to full moon day, right? It is increasing in size, right? Then there is one more term called as blue moon, right? So what is blue moon? Second new moon in the month is called as blue moon. As we know that after every 15 days, there is a blue moon. So consider any first of the day, first of any month, right? Consider it is a full moon day. Full moon, right? So it will take after 15 day, we can say this is no moon day or Amavasya, right? Again, after 15 days, there will be second full moon. So this second full moon is called as blue moon. Okay, so these are the different terms we are going to use. You should try to learn those terms. Okay, so this diagram is showing you how we are getting the reflection from the earth. So this is the sun is sending the light towards the moon, and moon is reflecting that light towards the earth. And only this is the earth, right? Only when there is a night, then only we can see the moon. From the day side, we are not able to see the moon, right? Then, okay, so positions of the moon and corresponding phases we can say. Here you can see the sunlight is coming from here, earth is here, right? And this is here we can say there is a full moon. Here we can see whole moon. Here it is decreasing, right? Like this. And again it shows the decreasing, right? It is increasing again, and again we will get the full moon, right? Like this. So this is very easy to understand. We already seen the phases of the moon there. Okay, sure. So let's move to the next point. Okay, so moon phases can be visualized like this one. When the day is zero's day, you can see only this moon. If days are increasing, moon will go here. There will be increase in its shape. Then it will move ahead. Then again we will get the full moon. There will be again two full moons. We already studied these things. Okay. Again here you can see the Earth is rotating around the sun and moon is rotating around the Earth, and therefore we can see the moon because of the reflection of light of the sun from the moon. Okay, so these are the different pictures you can see here. Okay, then some basic facts on which they could ask you the questions on the exams. So let's see what are the basic facts here. We already seen that size of illuminated part of the moon is visible from the earth, right? Increases each day after the new moon day, right? New moon day or no moon day, we can say. Then after full moon day, the sunlight part of the moon visible from the earth decreases. This we already know. Purnima, Amavasya, full moon day, or no moon day or new moon day, we can say, right? We never see back side of the moon from the earth, right? So when the we can say moon is back, we cannot see the never back side of the earth. We can only see the front side of the moon, we can say. Okay? The moon completes one rotation on its axis as it completes one revolution around the earth, right? Now we know that moon will take 28 days to complete one rotation around the earth. Similarly, it will take that much of days to complete one revolution around axis. Okay, and this you should know these two names. Neil Armstrong, you must have heard, I know. Okay? So Neil Armstrong was the first person to land on the moon. Can anybody tell me who sent these two persons, two astronauts on the moon? Which country? That's right, US, right? Okay, so actually at that time, 1960s, there was a race which is called a space race or sky race, right? Between Russia and US. The race was who will send the first man on the moon, right? Obviously, US sent the first one, that is on July 21, 1969. Okay. Then now let's talk about the surface of the moon. As we already know that man has already conquered the moon, means have went to the moon. We know a lot of things about the moon, right? So moon is barren. Barren means we cannot grow any food there. It is covered with dust. Gravity, we know the gravity, right? Earth has some gravity. What is the value of gravity? Anybody know? Yes, that is G is equal to 9.8 meter per second square. Right? On moon, gravity is 1/6 of this. 1/6 of 9.8. So what is the meaning of that? On moon, the gravity is 1/6. Now consider if you're jumping on the earth, right? If you're jumping on the earth, you do know how much height you will cover. If you jump on the moon, your height you will jump 6 times than larger than the earth, right? Because gravity is very small, so you can jump very high on the moon, right? So this is the about moon. Then it has some craters or ball-shaped cavities, something like this, right? So something like this, we can say craters means like this, right? If this is the surface, there is very deep craters will be there, right? Bowl-shaped surfaces. So bowl-shaped cavities are present on the surface of the moon, we can say. There are steep and very high mountains present on the moon. Those mountains are as high as the mountains found on the earth. Yes, which is the highest mountain on the earth? It's Mount Everest, right? Anybody know how much is the height of that Mount Everest? It is 8.5 kilometer. Very high, right? Similar mountains we can found on the moon too, right? Then there is no presence of water or atmosphere on the moon. Okay, there is no atmosphere. No atmosphere means obviously there is no gases present. So remember, their sound cannot propagate on the moon. Remember this part very clearly. Sound cannot propagate on the moon. So if you and your friend went on the moon, right? And you try to talk with each other, it is not possible, right? Your friend will never hear you because sound needs medium to travel, right? And moon does not have any atmosphere, therefore it is not possible, right? Then let's talk about something about the lunar eclipse. So what is lunar eclipse? So it occurs when moon, earth and sun, you can see the diagram also, right? Moon, earth and sun are very closely aligned with each other, and also we can say those are in straight line, right? And earth is present in the middle. So three, sun, earth and moon should be in one straight line, and earth is in the middle, we can say. Okay, that time the shadow of the earth falls upon the moon, right? Therefore moon cannot reflect the light of the sun, right? So what is the light moon receives? Light it receives is from the earth. Now earth is again planet. Earth cannot produce its own light, so we can say earth takes the light from sun and reflect back to the moon, right? This is the process, right? So this light is reflected from the earth, we can say, and in that case moon appears to be red color, reddish color, right? Therefore we can call it as lunar eclipse. Remember this part. Then simple question is there, why lunar eclipse does not happen every month, and why we see full moon even when the earth is in between moon and sun, right? So what is the meaning of that? We have seen in the previous slide that the earth is in between the earth and sun and moon, so there is shadow of earth on the moon, then only we are going to get the lunar eclipse. So why it is not happening every month, right? So there are reasons. What are the reasons? So let's see. Sometimes it is difficult to comprehend how can full moon even exist when moon appears to be behind the earth. So we have already said that moon is behind the earth. How we can see the moon, right? So you can see here the earth. This is the earth, and see the shadow of the earth. Where is the shadow of the earth? It is not in a line of the moon. Why? Because moon's orbit is tilted. Moon's orbit is tilted about 5 degrees. It is not exactly right the earth. It is tilted like this. Therefore, shadow of the earth normally goes above the moon here, we can say, right? Therefore, we can see the moon. If it was not the case, if 5 degrees inclination was not there, then remember we will always would have seen the lunar eclipse. We would always have seen the moon as the red color, right? But that is not happening because it is tilted. Okay. Then lunar eclipse occur when the moon reaches the orbital plane of earth near the time of full moon. So it should be full moon. There are two criteria, we can say. It should be full moon and shadow of the earth should be exactly on the moon, right? So those are not the, we can say, everyday event, right? So it should be full moon and they all should be in the straight line, and shadow of the earth should be on the moon, then only we can find a lunar eclipse. Therefore we cannot see them every month, right? Sometimes it will occur. Right? Here also we can see the orbit of the moon is tilted by 5 degrees. Therefore, shadows also we can see shadows are not coinciding. Okay. Sure. So there are some FAQs, right? Questions they could ask about the moon, right? First question: why, when the lunar eclipse occurs, we already seen that the Earth, Sun, and Moon should be in the straight line. Then only we can get the lunar eclipse, right? Then first man. Who is the first man? Yes, anybody? Neil Armstrong, right? Then Purnima is a full moon night or half moon night. Obviously, we know on Purnima there is a whole disk we can see, that is full moon night we can say. Okay, so this is all about the moon. Now let's talk about the stars and their life cycles, right? So stars, we know the closest star to us is sun, right? Around which our Earth is rotating. Is sun is the only star? No. There are a lot of stars in our solar, in our galaxy as well as universe, right? Okay. So here you can see why we can see only the sun, because sun is very close to us and therefore we can see it as bigger and very hot, right? It provides, it also gives us the heat as well as light, right? Other stars we can say those are a million times further away than the sun, very very far away, right? So we can see those stars are very small actually. So can we say the sun is the biggest star? No, sun is not the biggest star. Rather, I will say sun is a very small star compared to other star, right? Okay, so a lot of stars are very, very bigger and hotter. They have a lot of energy, a lot of heat in themselves, right? Okay, so this is the night sky you can see. Normally, you can see it. No, that's not a big deal, right? Then so now sun, what is the distance of sun? As I said, sun is very close to us. Very close to us means comparing with the other stars, but still it is very, very far away. You can see 150,000, lot of zeros, then kilometers. So very large distance, right? Let's talk about the other stars. The nearest stars to us other than sun is called as Proxima Centauri. You can see the distance, right? So almost there are 4, 7, 10, 13, 4 into 10 raised to 3 kilometer, right, from the Earth. Now, these units are very, very difficult, very large units. So quantities becomes very large. Therefore, what we can do, we can use the light year unit. We have already discussed about the light year. Light year is the distance which light travels in 1 year, right? So here you can see light year is the distance traveled by light in 1 year. Okay, speed, I have said 3 into 10 raised to 8 meter per second, or we can say 3 into 10 raised to 5 kilometer per second. So if you do some very easy calculations, consider, we know the time. Time is equal to what? Distance upon speed, right? So if what is the sun's distance? This is the distance. So 150,000, then again 3 zeros are there, divided by its velocity. I can see the velocity here, 300,000. Right? If I calculate this one, I will get the answer as 8 minutes. This answer will be in second. We again have to convert it into minutes. We know how to convert it, right? Good. So we will get the answer. It's 8 minutes, or we can say it is actually 8 minutes 20 seconds. So the light from sun reaches to us in approximately 8 minutes. So in the morning, when we say sunrise, sun rises, right? Actually, it had already rose 8 minutes before, right? We saw that later after 8 minutes. Okay. Similarly, the second star which is closest to us, we said it is Alpha Centauri, right? Now, light starting from that will reach us after 4.3 years, right? So remember this one. So consider if this light started traveling from Alpha Centauri right now, it is going to take 4.3 years. Obviously, you must have covered your 12th as well as JEE, right? Then it will reach to us, right? So it's a very, very long distance. Okay. Then okay. So about the stars, if you talk about the stars are very, very old. They are literally million years of old, right? And some stars are there even before the Earth was born, right? Okay, so you can see, consider this star 4.3 light years. It takes the 4.3 light, right? So consider some stars which are very, very far away. If the light from that will take, consider 100 years to reach Earth, right? So one star you are watching right now was there 100 years ago. You are just watching it now. So we can say your future is the star's past. So you are looking into the past of that star. Okay, because light took that much of 100 years to come to you. Okay, even though the light speed is very, very high, it took a lot of time to come here. Okay. Similarly, light emitted by some stars at the current moment will reach the earth millions and billions years from now, right? And so distance of them will be very, very large, we can say. Then simple thing why we can see the stars only during night, because the obviously there is a light of sun. Still those stars are at that point, but light of sun faint the light from the stars, other stars, because other stars are very, very large distances, right? Therefore intensity becomes less. Even we can say, even at the night stars are not visible in the cities. Why? Because we do have a lot of lights with us. So obviously those overshadows the lights from the stars. Why? Because again stars are very, very far away, right? Then then let's see how the stars move in the night sky. Now we know that the earth rotates from west to east. Similarly we can say star appears to move from west to east. Actually, they are moving in the reverse direction. You can consider the example of the moving train. When you are in the train moving forward, you can see the trees moving backward. Similar to this, if the west to east, Earth is rotating west to east, stars should appear. Stars are appearing in their reverse position. We can say so. Stars appears to move from east to west, but they actually move from west to east, similar to Earth's rotation, right? Due to same reason, we see the sun appears at the east and sets in the west. Okay, then we have already seen why the stars twinkle. As I told you, that light traveling in the zigzag motion. Why? Because of the Earth's atmosphere. There are a lot of layers and density. You can say change in density is there. Therefore, we can see the stars are twinkling. Okay. Then let's study about the light cycle of the stars. Now we know the stars are formed due to the clouds of gas and dust, which is called as nebula. Okay. Then there is a nuclear reaction at the center of the stars, we can say, which is providing the enough energy to that, so that the stars will shine for a lot of times. It will provide the light there, right? But still, as we have already discussed, that stars also have some lifetime. They also born, they also die, right? So this lifetime depends on its size. So obviously massive stars burn their fuel much faster than smaller stars, right? So bigger the star, it will have less life, right? So it may only last for few 100,000 years, right? Their life will be very small compared to other stars, even though we can see the few 100,000 years are not a small life, right? Human only have the maximum of 100 years life, we can say, right? Smaller stars. So what we have seen, massive stars have the small life because they burn their fuel much faster. Smaller stars last for several billions of years, we can say. Okay. Then hydrogen fuel that powers in nuclear reactions within the star. So in our sun also there is a hydrogen fuel, right? When this hydrogen fuel will run out, what will happen? Our sun or any other star will enter in their final phases, right? So fuel in the core of any star, which is hydrogen fuel, when it's we can say when it's finished, then the star will enter in the final position, right? And over time it will start expanding, it will get cool, and it becomes red giant, right? So what is happening? Again, I will repeat, at the core hydrogen fuel is there. When it begins to run out, right? What happens? Star enters in its final phase. In final phases, what happens? It starts expanding, we know it is hot, very hot star. It starts to get cool and it becomes a red giant, right? Its color becomes red. Okay, so so about the small stars like sun, right? As I said, sun is very small compared to other stars, right? For there are three different we can say types of the stars or the phases of the stars. For small stars, which are like sun, they go very peacefully and beautiful day, right? And after that they becomes white dwarf, right? So that sees them pass through planetary nebula,